Hello everyone. In this video we will be going over stem and leaf plots, the rules behind them, and how to make your own. Let's start by thinking about what other kinds of graphs are similar to a stem and leaf plot. Stem and leaf plots may seem unique, but are actually very similar to other types of graphs. A frequency distribution, for example, is similar to a stem and leaf plot, but rotated 90 degrees and uses bars to represent the number of values in a data range. These graphs help us see how spread out a sample may be and where the majority and minority of the data may lie. Let's have a look at the rules behind the stems on a stem and leaf plot. The number of stems must be 6 to 13. Well, if we look at our example here, the example on the left has 6 stems, while the example on the right has 7 stems. Our next rule is that the numbers must be consecutive or repeated. And if they are repeated, they may only repeat twice or 5 times. Looking back at our examples here, the one on the left is consecutive. It goes up by 1 each time, -2, -1, -0, which is weird, but it is a thing, 0, 1, and 2. And the example on the right is repeating 5 times. We only see 2 4s, but that's because of stem rule number 4 that we will get to in a minute. Our next rule here is stem rule 3. The stem value must be included if it is not 1. Our example back at the left has a stem value of 100. And our example on the right doesn't show a stem value, so it must be 1. We'll go over what a stem value is later in the video. Our stem rule 4 is that there must be at least 1 leaf in the first and last stem. Let's say we're making a stem and leaf plot, and after we fill up all the data, we have no leaves in the first one, for example, in this example I have here. What we would do in this case is we would erase the first one. And because of that, we are down to only 5 stems, and we would have to actually repeat more than twice in this case. But we'll get over that once we get to the procedure of stem and leaf plots. Let's move on to the rules behind the leaf on a stem and leaf plot. Our first rule is that the leaf value is the number following the stem value, no rounding. If our original number was 76.999, in our 70 bracket, we are going to put 6. We are not going to round up to 7. This is what leaf rule 1 is talking about. Leaf rule 2, when stems are repeated twice, the leaf brackets are 0 and 4, and 5 and 9. And then when the stems are repeated 5 times, the leaf brackets are 0 to 1, 2 to 3, 4 to 5, 6 to 7, and 8 to 9. Let's go over examples up here. So our example on the right is an example of numbers repeating 5 times. So we're going to have 5 different brackets. 0 and 1 are in the first one, 2 and 3 are in the second, 4 and 5 are in the third, 6 and 7 would be in the fourth, and finally 8 and 9 in the final bracket of 5s. Our third leaf rule is that numbers are ascending order if positive and descending order if negative. Looking back at our example, we see our example on the left. These negative numbers are going down 9, 5, 1, 3, 0, descending order. But when it gets to the positive end at the bottom, it goes up in ascending order, 1, 3, 4, 5, 3, 6, 8, 8, 9, and so on. Finally, the last leaf rule is that no commas or dashes are used between numbers. As you can see in our example above, there are no commas or dashes in between any of the numbers in the leaves. Let's take a look at the recommended approach for creating a stem leaf plot. First, we figure out our stems. We compare the lowest and highest value among our sample. We fill in the missing digits with zeros, and we figure out if we need to repeat any stems. Our lowest number is -357. And our highest value is +1010. So if we were to get -357 written here, and 1010, we can see that 1010 is one digit more than -357. In this case, we would turn it into -0357, so that there's the same amount of digits compared to 1010, the highest value. After we fill in the missing zeros, we can easily see the stem value, which is the first digit. So it's going to be -0 all the way up to 1. Unfortunately, this leaves us with 3 stems. If we recall from earlier, the first stem rule is that there must be 6 to 13 stems. This shows us that we have to at least double and maybe repeat 5 times. Let's try doubling. If we were to double these, -0, -0, 0, 0, and 1, 1, we see that we have 6 stems, which does follow the rule. Let's try this out with 6 stems here. -0, -0, 0, 0, 0, and 1, 1. Our next step would be to fill in the leaves. To fill in the leaves, we just look at the number following the stem value. Our first number, -0357, the value after 0, -0, is 3. Recall as well that the leaf rule states that when repeating twice, the brackets for the numbers would be 0 to 4 and 5 to 9. Since we're in the negative, it would start 5 to 9 or go 9 to 5 backwards. And then this bracket would have the 0 to 4, where our 3 lies. So we're going to put it here. Our next data in the sample is -301. Again, we would add a 0 in front, so that it's the same amount of digits. And we could see easily which one is the leaf and which one is the stem. This is another 3, so we'll just throw another 3 there. And now it's easy to see that this would be a 1. And -0.005. If we were to fill in the zeros here, it would look a little something like this. -0, 0, 0, 0.005. The stem and leaf is all the way over here. -0 is the stem and 0 is the leaf. Let me throw 0 in here. Next up, we have another decimal number, 0.003. Similar to our last number, the leaf value is going to be 0. Next up, we have the number 58. If we need to visually see how it lines up as well with the digits, 58 would have 2 zeros in front of it, meaning the stem is 0 and the leaf is 0. It would be the same with 78, a 2 decimal number, and the same with 99, another 2 decimal number. Recall, we do not round up to 100. We never round in a stem leaf plot. Our next number would be 125. 125 means that the leaf would be 1, and the stem would be 0. Oh, I put that in the wrong bracket. Remember the brackets here, since we're positive, is going 0 to 4, and 5 to 9. So we'll put the 1 in here. After that, we have another 1 for 168, another 1 for 169, a 2 for 268. I'm just going to have to erase the brackets at the side so that I have room. A second 2 for 268, yeah. A 3 for 348. And then our next number, 547, would be in our second 0 bracket as a 5. And then 599 as well. And then we're at our maximum number, 1010. 1010, the leaf would be 0, and the stem is 1. Stem leaf. Now recall our fourth rule in the stem and leaf plot is that there can be no empty stems. That would mean that we would have to erase the first and last stem we created. Unfortunately, doing this means that we're dropped down to 4 stems and that repeating twice was not the right thing to do. Let's see what would have been the right thing to do, repeating 5 times. That's our only option left after all. So we're going to repeat 5 times, making a total of 15 stems. But as you can see, after we fill in the leaves, we're going to have to remove some of the empty ones. So let's take a look at what happens when we repeat 5 times. -0, -0. All right, so we have our stems written down. We're going to try to fill in the leaves, starting with -357. We knew from trying doubling that the leaf in -357 is 3. Looking at our brackets here, remember we're negative. This first one is going to be 9 and 8, then 7 to 6, 5 to 4, 3 to 2, and 1 to 0 for the first 5 brackets. So -357 is going to go into the second last -0 bracket. We're going to put 3 here. Again, -301, same bracket. -155 is going to go into our last -0 bracket. -0.005, we know that it's going to be a leaf value of 0, and that would also go in our last bracket. Next up, we have 0.003. Since we're back in positives, we're going in ascending order now. 0 to 1, 2 to 3, 4 to 5, 6 to 7, and 8 to 9 are the brackets for our zeros. So 0.003 is going to be a 0 in the first bracket. 58 is going to be another 0 in the first bracket. Same with 78 and same with 99. 128 is going to be a 1 in the first bracket. 168 is going to be a 1. 169 is going to be a 1. Next, we're at 221, which is a 2 in the second bracket. Throw that there. 268, another 2. 348, it is the same bracket. 2 and 3 are part of the same bracket, so I'll put that there. 547, that is in the third bracket of zeros. Throw a 5 here. And same with 599. Finally, our last number, 1010, well, our stem is 1 and our leaf is 0. The first bracket has 0 to 1. So our first 1 bracket is going to have our 0 for 1010. Now we get rid of the stems, with the first and last stems with no leaf values. So we would get rid of all of these up to our 10-10 bracket. And here we would get rid of all the top ones up to our 33. And we leave the two empty stems in between. This is fine in between here. It's okay if those are empty. Now, as we see, we have 3, 6, 8 stems. We have followed the first stem rule, and we have completed our second step in creating a stem and leaf plot. The final step to our stem and leaf plot would be to figure out the stem value by taking any value from the stem and leaf plot and trying to figure out what you must multiply it by to obtain the original number, give or take some. What do I mean by this? Well, let's look at our stem and leaf plot here. If we were to imagine the line dividing the stems and leaves as a decimal point, any value here could be turned into a number. So let's take our maximum of 1.0. 1.0 was originally the number 1010. That's the original data that gave rise to our point in the stem and leaf plot. So what did we need to multiply 1.0 by to get into 1010? Well, 1.0 times 1,000 would give us 1,000, right? That is close enough that we could see that that would be the stem value. Our original number being 1.0 times 1,000 gives us closest to 1,010 that we're going to get. If we were to multiply it by 1.0 times 10,000, that would be way too big because it would be 10,000. It's not close to 1010. And if we were to multiply 1.0 by 100, it would only give us 100. Still very far from 1,010. So the closest we get is by multiplying by 1,000. If we look at our minimum value, it was on our stem and leaf plot as negative 0.3 if we imagine the line dividing the stem and leaf as a decimal point. What do we multiply 0.3 by to get its original value? Its original value is negative 357. So if we multiply 0.3 times 1,000, we will get 300. That is the closest we're going to get to 357 because the stem value can only be a multiple of 10. Or it can only start with 1 and end in 0, right? 10, 100, 1,000, 10,000, and so on. So we know that 1,000 works because 0.3 times 1,000 gives us close to our original value, 357, negative 357. And 1.0 times 1,000 gives us 1,000, which is close to our 1,010. Remember, a stem and leaf plot doesn't have to tell you the exact number the original data was. It's just used to show how spread out the data is. So we fill in our stem and leaf values. Stem value, as we said, was 1,000. And the leaf value is always the stem value divided by 10. In this case, 100. This concludes our procedure for creating a stem and leaf plot. Again, you can do it in 3 simple steps. We figure out the stems by comparing the highest and lowest values among our sample and filling in any missing digits with zeros. Next, we fill in the leaves and we get rid of any stems that don't have a leaf if they are the first and last stem. We leave stems in the middle that are empty like we saw in our example right here. These 2 stems are empty, but we leave them anyways. Finally, we figure out the stem value by taking any value from the stem and leaf plot and figuring out what you must multiply it by to obtain close to the original value, very close to the original value. This concludes our video for the stem and leaf plots.